Okay, I'm just going to talk about connecting standard deviation and distributions. Okay, so first of all, let me scroll this way a little bit and we'll do. So if you remember, there's lots of different types of distribution, right? We have our normal one, which is symmetrical, as best I can draw it. Okay, then we have a U-shaped or bimodal, which will look something like this, with two humps, two mountains. We could have uniform, where it would be straight. Now, uniform does not have to be perfectly straight either. Oops. Uniform does not have to be perfectly straight. If we have something that's like this, a little bit up, a little bit down, all around the same, I would classify that uniform as well. And then we'd have left skew and right skew. So if I was drawing a left skew, it would look like that. Now the definition is that the mode and mean, sorry, the mean and median are to the left of the mode. So the mode's right here, and then the mean and the median would be somewhere around here. Now, the way I think about it in easy sense is if pretend you're stepping on it. In this sense, my big foot here would be stepping on the left side, pushing it right. And then a right skew would look like this, where I'd be pushing down on the right side of it. That's a horrible foot. On the right side of it, pushing everything left. But that is a right skew, and this one up here is left. But we're going to be talking about this one here. We're going to connect that with a with standard definition, standard deviation. So here's your perfectly normal curve. This would be a perfect one here. Okay, with the mean median mode happening right in the middle. Now, what standard deviation set does is it tells you how compact or spread out your data is. So let's say I have two classes. I have class A and I have class B. Okay. Now, we looked at their final exam marks. And let's say they both have an average, a mean of 80, for example. They both have a mean of 80. But this first one has a standard deviation of, let's say, 5%, where this one has a standard deviation of 2%. Okay. So I'm gonna actually put them on the same chart, if possible. So let's say my standard deviation of 5% looks like this. Okay. Now it's not gonna be perfect, I know, but now the standard deviation of 2% is going to be the numbers or the spread of the data is going to be closer together. So you can see there, the purple has a wider range of data, a wider range of data points or spread of data, where the red is going to be closer together. Okay, so the red, since its standard deviation is closer, its standard deviation is smaller, the data is going to be a little bit closer. Another example of this, let's say you have two athletes. You have athlete A. Let's take basketball. Basketball is a good one. So let's say basketball player A. Let's call this Shea. Shea Gilgeous-Alexander is really consistent. Over 3 games, he scores 30, 28, 32, 34, and 30 over his 5 games. So his standard deviation, now if we projected this all the way up through a season, let's say his standard deviation every day was 4 points. And let's say his mean was 30. Okay. So his standard deviation would be like this. So he's really consistent. Okay. But then I had player B, let's call him Kyrie, who would score 30, then he scored 40, then he scored 20, he scored 15, he scored 45, etc., etc. Okay? Let's say they both have the mean of 30, but his standard deviation is 8 points. So he's going to have, can I draw it? He's going to have higher highs, but he's also going to have lower lows. So like his high might be 60, but his low might be 5. Okay? So you can see here, standard deviation, squeeze their data together. Now, in some sense, if you're doing research, what will happen is if you have two people doing the same research, you might look for more consistent data. Who has the more consistent data, which this might reflect. And the way this connects to standard deviation is in the middle here is our 0 point. Okay? And the next lesson we're going to work on this. Now, on each side of your standard deviation, there's 3. So each side of your middle, or your mean here, there's 3 standard deviation points. So a plus 1 standard deviation, plus 2 standard deviations, and plus 3 standard deviations on this side, and then minus 1, minus 2, and minus 3 on this side. So let's say we went back to Shay here. Let's go back to class. We had an average of 80, so we had a mean of 80, and we had a standard deviation of, what did I say, 5? 5. Okay. So that means we're 80 here. Now, if we look here, we're going to add a standard deviation. So 85 here, 90 here, and 95 here. And then we're going to take it off, which means 75, 70, and 65. So that would kind of be the spread of marks. Generally, low mark would have been 65, high mark would have been 95, average of 80. And if we look here, of the other one, we still have an average of 80, but a standard deviation of 2. So if I do this here with it, I start at 80 again. This is going to be 82, 84, 86. I'm going to minus off here, so 78, 76, 74. So you can see the range of marks is going to be much smaller. The high mark for the red is going to be 86 compared to 95, and the low mark is going to be 74 compared to 65. So the range of marks is much smaller. So from 74 to 86 is going to be the marks. Okay, so that's just an example of how you can connect standard deviation with a normal curve. Okay, so go on and watch this how to calculate standard deviation video, and there's a note there as well.